Multiply and divide monomials. What? Monomials. Okay, let's define what a monomial is real quick here. So a monomial, some of you have probably jumped ahead of me if you remember your kind of your Latin prefixes, right? We've got mono, bi, tri. Mono means one, bi means two, tri means three. Monomial is a very simple thing. It's the way we describe a number, or a variable, or and let's highlight this here, the product of the two. Yeah, so that's what a monomial is. And a monomial, as an example, could be 7, or it could be x, or it could be 7x, the product of a number and a variable. Additionally, we can then include because we're building off of our powers and exponents lesson here, we could say 7 squared and x to the 4th, and then kind of rewrite these as 7 squared x to the 4th. And now we have kind of like a super monomial. All right, so that's monomials. We're going to multiply and divide monomials, and when we multiply and divide monomials, it's going to look like this. Okay, let's look at some examples of finding the products of monomials. So this is the products here. Products is the solution to a multiplication problem. So if we look at the first one here, let's write it in expanded form, and then we'll get an idea of this. So what's the exponent on 2 when there's no exponent here? How many factors do you see of 2? There's 1, right? So we can put the 1 there, that's fine. So in this we've got 2 times 2 times 2 times 2, that's our 2 to the 4th, times 2, that's our 2 to the 1st. And then we can just rewrite that with exponents to say our base is 2, and then how many factors? 1, 2, 3, 4, 5 factors. 2 to the 5th. Do you notice anything here? Do you notice anything in terms of our exponent? Like here's our exponent, here's our exponent, here's our exponent. Do you notice something in terms of the base? Here's our base, here's our base, here's our base. Okay? Let's look at it over here. I've got b squared, so that's b times b, and then b to the 5th. 1, 2, 3, 4, 5. Don't need that there. So now how many b's do we have? 1, 2, 3, 4, 5, 6, 7. b to the 7th is our answer. Do you notice something here between your exponents and your bases? I hope so, because what we see here is when we're multiplying similar bases, like bases that are the same, the base stays the same, and what we end up doing is just adding the numbers of the exponents together, right? Because we're going to have 5 factors, 4 factors plus 1 factor gives us 5 factors. 2 factors plus 5 factors gives us 7 factors. And it works out to be the right answer too. So let's look at it here. Like 2 to the 4th is 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 4 is, that's 16 times 2 is 32. 2 to the 5th is 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Okay? Now, this is a special case down here, so we'll look at this a little bit differently. When we see things that have different coefficients, we're going to have to multiply those coefficients together separately. So in this, we're going to take our 3 and our negative 3 and our 4, and we're going to say negative 3 times 4. That's one part. Then the next part will be x squared times x to the 4th. Now we're going to use kind of that our understanding of how those exponents work here, as opposed to writing them in expanded form. But you could always write them in expanded form. In this case, we have negative 3 times negative 4, which is going to give us negative 12. And then we have x to the second times x to the fourth, so that's x times x times x times x times x times x. And that just gives us negative 12x to the sixth. There's a bit of a twist here, so just be sure you don't do this. When you come back to this problem, 2 to the fourth times 2 to the first, because we're just multiplying like bases, the base is not going to change. This just says there's 4 factors of 2. This says there's 1 factor of 2. And with the 2 of them, there are 5 factors of 2. This does not turn into 4 to the 5th. No, it doesn't do that. These bases just stay the same because they're here. The difference down here is we can rewrite this multiplication, because that's what's happening here in this monomial here. This is multiplication, negative 3 times x to the second, 4 times x to the fourth. We can just rewrite that multiplication so that it sits like that. Okay, let's get to the second half of this now, which is dividing monomials. And in dividing monomials, what we're looking for is a quotient. Quotient is the answer to a division problem, as you know. And this is something similar is going to happen here. So let's look at this way. I've got 7 to the 5th over 7 to the 2nd. Let's write it in expanded form first so we can see what's happening. I've got 7 times 7 times 7 times 7 times 7 divided by 7 times 7. Now, one of these things that I absolutely love about math is the way we can take something and divide it by itself and it gives us a 1. So that's good for us. It helps us to work through these problems. When we look at this, we have 7 to the 5th divided by 7 to the 2nd. 7 divided by 7 is 1. So these just become 1 and 1. 1 times 7 is just 1, so there's no problem there. And then these two can become 1 also. Now I have 7 times 7 times 7 over 1. Let's just write this back in exponential form. And we find our answer is 7 to the 3rd. Now let's look here. We've got that relationship. What do you notice about that relationship? It's a fact family back from first grade. What we notice is we're going to subtract from the numerator the amount of the denominator's exponents, and the base stays the same. So 5 minus 2 gives us 3, 7 to the 3rd. If we take that, let's take it to the next problem. We have x squared, or x to the 3rd divided by x squared, which means that our algorithm tells us that our base is going to stay the same, and then we'll have 3 minus 2, which leaves us 1. X to the first we know is just x. We usually don't write the first because we don't necessarily have to. It means the same thing for both, and we save the ink. Now this is like the serious problem now. So now we've got 3 different things happening here. We have a numerical, we have 2 variable bases, and when we look at this, we're going to do all these together as each piece though. So I've got 16 divided by 2, which is going to leave me 8. I got x to the 9th over x to the 3rd. Now I'm going to write the base here. What's the answer? X to the 9th divided by x to the 3rd. I know what you're thinking. I hope it's the right thing. That is x to the 6th. And let's take some insight into that one real quick, because it's not x to the 3rd. So I have x to the 9th. So this could be a lot of x's. 1, 2, 3, 4, 5, 6, 7, 8, 9. Over x to the 3rd. 1, 2, 3. Now, let's see how many x's are left over when we reduce these by dividing x by x. So x divided by x is 1. X divided by x is 1. X divided by x is 1. 1, 2, 3, 4, 5, 6. X to the 6th. Okay? Remember, when we're using these, multiplying and dividing by these monomials, we're actually doing multiplication and division, but the way we see it, though, in terms of the algorithm here, is it's subtraction of those exponents, okay? This is still division. 16 divided by 8 is 2. This is still division. X to the 9th divided by x to the 3rd is x to the 6th. But we can shortcut that to say x to the 9th, x to the 3rd, subtract the 9 from the 3. That gives us what we need. Now we have y to the 5th divided by y to the 2nd, and that is y to the 3rd. All right, let's go to the vocab. In this lesson, we had monomials. And we know that is a number or variable or the product of both. We also had, let's just not forget what product is and quotient. Like those two things. We got to keep in mind this language. The language is what matters thematically. So as you go through math year to year, it's the language that has to carry with you so that each year gets a little bit easier because you're accessing your past.